Welcome in the second part of the introduction to the HDK sensor. It's very difficult to record the movie without anyone cuts. So let's start. Today I show how to use the parallel mode and UART mode. First, what we do, we configure the system, the sensor. We start, we need connection, we read present configuration, we choose the UART mode, the right configuration, read again. Okay, we have the configured sensor. Now we must change the mode for the run mode. Okay, still connected. Now we back to our oscilloscope, and so we have the digital value. Pink line is analog output, and the blue line value transmit from sensor. Bottom value, the low byte D2 at this moment, top value high byte 3 and low byte 6C770. Okay, so here we have yet measure and reference amplitude. See that? Okay, we disconnect the sine waveform and we back to our configuration. Now we change the output for parallel port. So we must again disconnect the supply, connect the jumper. We start on the supply, we back to application, we change the focus a little. Okay, init connection, read configuration, disconnect the UART mode, and we choose the parallel 10-bit mode. You write configuration, we read out configuration, and we back to our sensor disconnect mode. We connect the clock signal and we connect supply. And here we have 10 digital lines connected directly to the serial logic analyzer, and we follow for the cable, and we back to the application which supported the serial logic analyzer. And what we do now, we start the trigger. Yes, we move the twice adjuster, and we back to our application and we stop the trigger. And so here we have we change the focus. Here we have a 10 line with data. This line is a clock. Okay, how we zoom out the value, we see here the clock, and the last line is the analog line read it from the analog output. And on the right side we have a digital value, so increased value, decreased again, and we have increased and decreased again. And like you see here, this is typical 10 bits. Here is a maximal area of the maximal value, and probably is somewhere here. Okay, now I show how to works the 8-bit parallel port. 8-bit parallel port is downsampled. Then some people they can use only the 8-bit in our processor. Then this mode is also allowed. And again, we disconnect supply, we connect configuration sensor with ground, we connect supply, we back to our application, we start init connection, we read configuration, and we change for the 8-bit mode. Right configuration, readout, and okay, we back to the configuration. From configuration to run mode, we connect clock and we connect supply. We back to our application. Okay, application focus. We start the trigger. We move twice of the adjuster. We stop the trigger, and well, we have only 8 lines with the data. The last one is analog value, and here is the typical clock. If we look at in the digital value, here we have a value down sampled only for the 8-bit. The maximal is somewhere here, decreased. Okay, this is a hint when we click on the digital value, it shows us where exactly the value is on the logic scope. Here we choose the value with, for example, this one. Probably this will be maximal value. Yes, the value is somewhere here. So, like I mentioned before in part 1, the E2C mode is not supported yet. And here we have a magic button yet active on the edge. What this means? The parallel modes can be active in the 2 methods. Without this button, the parallel port works permanently. Don't need any external edge to the activate of the data. But if we mark this check button, the data on the parallel port are only set when we get the rising edge on the port. And what this means in practically, we can change the flow of the transmission. That's a hint to use the another type of the steering of this sensor. And this is all how this can work. All details will be possible to read in the datasheet. Hello, bye bye.